So we're going to kind of split our note-taking into 2 different days. Today we're going to be going back and talking about cube roots in particular, and things to remember. We're going to touch on rules from Chapter 5 that we talked about, monomial rules, and then tomorrow we'll get into more details. So again, we're going to explore cube roots. In addition, I'm going to ask you to memorize some perfect cubes. From 1 to 1,000. Okay? Now, those are the results. I'm not asking you to cube 1,000. They are the perfect cubes. Okay? And then let's see what else. We're going to do some explore fractional exponents. Now, you got to be honest, there is a teeny, itty bitty, teeny little bit of information in your textbook. It's like an afterthought of a lesson, half a page, and they just kind of launch into stuff like you have background on this. And I know it's the first time that you've ever seen it. So I kind of think in the old standards, it was like you don't have to deal with this for 2 more years. And now in the new standards, like this is really how we want you to think about your numbers, is dealing with these fractional exponents. So it is a little bit different. So let's start with a cube root. So I can give you the lesson. It's 11:05, but again, like I said, you're not going to get much out of it. I'll see if I can find a video for you guys that I'll attach it to your homework in addition to this one. See if Virtual Nerd has a good one or something. Okay. So let's talk about a cube root. And what do you guys think a cube root is? So I'll give you a picture of what it looks like. So what does that mean? What does that mean? What are they asking you to do when they're saying, hey, what's a cube root? Because you guys are pretty good about what is a square root. We've done quite a bit of that. Lucas?
It's like the same thing as a square root, except it's like multiplying it 3 times instead of 2.
Okay. So what we're looking for is what number multiplied 3 times, right? Okay, not by 3, but 3 times. Okay, so what number times itself times itself? So that's what we're trying to figure out, is can we take that x value, and is there a number times itself that I can pull out? Okay, so that's our cube root. Now, I do want to point out a vocab. That 3 that's in the crook, we know that to be cube root because we've talked about it before. But I just want you to know that in general, that's called an index. Okay, and things that we're going to be talking about, and also in the 2 Common Core books I've looked at, they're using that word index. Let me give you a little gap between there. So an index is whatever that root value is. In a square root, the index is a 2. In a cube root, the index is a 3. Okay. All right, so again, this guy, when you see this picture, you're asking this question. What is the cube root of x? Oops, root of x. Still looks like an F, sorry. Bless you, bless you. Hey, the air conditioning hasn't even come on yet and you started sneezing. Okay. All right, so in order to get to 1,000, what is being cubed to give you 1,000? Jason? 10. So what I'm asking you to memorize are the cubes of 1 cubed through 10 cubed. So it's really 10 numbers that you have to memorize, and you probably already know a couple of them. So there's just some weirdos in the middle. And again, when you get the quest back, you'll realize, oh my goodness, I didn't recognize that perfect square. If I had recognized that perfect square, this problem would have been so easy. And when we stop taking the time to memorize things, then we are slowed down and we have to go other means, and that, again, takes time away, which is why we're not finishing our tests in a timely fashion. because we don't have those bases of knowledge. So let's write them down. To memorize. And this is not a polite request. This is a command. Memorize. So 1 cubed is 1. And again, whenever we're memorizing, we actually have to be flexible in our memorizing, that it needs to go both directions. So not only do I need to know that 1 cubed is 1, I also need to know that the cube root of 1 equals 1. So that's the whole idea, the flexibility in our thinking is to go both directions. 2 cubed is what? 8. And the key thing you need to recognize is that the cube root of 8 is 2. Okay? That flexible thinking. I put the air on, it's still hot in here, I apologize. The room is cold at the bottom. We get 3 cubed is 27, and the cubed root of 27 is 3. 4 cubed is 64, and the cube root of 64 is 4. Did you guys ever wonder why certain people do really well at math competitions? You guys ever thought about that? You see these kids and they just bam, 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 bam. They're so bright. It's memorization. It really boils down to that they don't spin their wheels trying to figure out something because they have all these facts already memorized. The cube root of 125 is 5. So probably up through this, you may be fairly familiar with these, and then it's starting with the 6 through 9 where you may not be as familiar. So again, what are things you can do to help yourself memorize facts? Flashcards, right? They work. 6 cubed, anybody? I am hearing some mouthing. Be brave. 216. 198. No, 216. Nice try. Cube root of 216 is 6. 7 cubed. This one comes up a lot. 343. It can't, oh, sorry, it is 240. No, it is 343. It couldn't be 243 because that's barely above 216, which is 6 cubed. So this one, for some reason, comes up a lot. I think they just, because they realized, hey, the only way you're going to know this is if you've memorized it. 8 cubed? 512. So the cube root of 512 is 8. And then 9 cubed? 729. And the cube root of 729 is 9. And then we have 10 cubed is 1,000. Bless you, bless you. And the cube root of 1,000 is 10. So let me just take a moment to justify how I got this second group of problems all the time. Okay, so let's start with, let's do just 27 as a demo. How do I know that the cube root of 27 is 3 if I haven't memorized it? What could I do to try to figure out what the cube root of 27 is if I haven't memorized it? Aiden.
Factor it.
I can factor. So what would you write?
Square root of 9 times square root of 3.
Okay. Is that done?
You can factor 9.
Okay.
3 times 3.
So what I end up with at the bottom here is the square root of 3 times the square root of 3 times the square root of 3, or 3, the cube root of 3 cubed. Now, remember what we said the exponent version of a square root was? What's the exponent version, or excuse me, the fraction version of the square root of 2? So just as when we had this, we said that's the same as x to the what power? 1/2. So what do you think it's going to be when it's a cube root? Okay. So mathematically, what's happening in this problem here? Oops, sorry, I did not do it that way. I'm going to have 3 cubed, and I want to take it to the 1/3 power. Okay, so what do the monomial rules tell us to do when we raise a power to a power? We multiply, right? And what's 3 times 1/3? If I have a whole number exponent, that means that guy is no longer stuck behind a radical, or under a radical. He's outside. He's found freedom. And there's your answer is just 3. Yay. So that's the justification for how we can get that answer. The trick is to look at a number and say, okay, what do I have 3 of stuck inside of that number? Okay. So again, memorization is helpful. It goes through, but I do need you to understand why it works. Okay. All right, so let's do a couple practice problems along this line. So directions are going to just say simplify, which means do all the math you can do until there's no more math to be done. By the way, what happens when you take a square root of a perfect square? The radical goes away. Thank you, Ethan. You get a gold star for today because that's absolutely right. It's the same thing when you take the cube root of a perfect cube. When you're able to do what it asks you to do, the radical has done its job and it's gone. It doesn't stay. It doesn't linger behind. Okay? So, let's say we haven't memorized. And we don't know what the cube root of 8 is because I'm like, well, there's 1 8. How could I have a cube of it? So, what do we know factors of 8 are? And so what we just do is prime factorization. Okay? Amanda? 4 and 2. Keep breaking down. What are the factors of 4? 2 and 2. So this problem becomes the cube root of 2 cubed. Now remember what we talked about with squares? If I have a square root and I have an exponent of 2, what do I know happens when I take the square root of that number? It's more than just the radical goes away. What happens? They kind of, in a sense, cancel out, right? Because you've got a exponent, 2, times a radical 1/2. 2 times a half is 1. And they kind of, in a sense, cancel each other out. So this is the same thing. If your root, your index, and your exponent match, what comes out? What's the answer? The radicand. Remember, he's called a radicand. The radicand comes out. So there's that answer. All right? Again, let's say that you don't know this. Cube root of 64. Okay, well, I can't take cube root of 64. I don't know. So break it down. What could you break it down into? Maddie? 16 and 4. What else can we do? 4 and 4? Now, I'm going to say, let's say that you're so excited about doing prime factorization because it's been a couple years since you've done it, that you kept going. And you said, oh, there's a 2. Yes, there's a 2, 2, 2, 2. Whew, I'm so excited. And then you go, okay, I've got the cube root of 2 to the 1, 2, 3, 4, 5, 6. Oh, they're not the same. They don't cancel out. Don't panic. Don't fear. Because we can apply what we know. How do I write the cube root of the cube root as a fractional? Yes, as a fractional exponent. Say again. 1/3. What's 6 times 1/3?
2.
What's 2 squared? So even if we get overexcited and we really go down to basics, if my guy goes in, that's great. I'm going to show you an example, not quite yet. What if my guy, oh actually I will, what if my guy doesn't go in? What do I do then? So let's look at this problem. What if I asked you to take the cube root of 16? Is 16 a perfect cube? No. All right, so what's our option? Start factoring. All right, well, give me some factors. I heard 4 first. So 4 and its partner 4. How many 4s do I have? 2. Not enough. Keep going. I got 2 and 2. I got 2 and 2. I get the cube root of 2 to the 4th power. Okay, I'm going to blow your mind right now. You guys ready to get your minds blown? All right, here we go. We've got 2 to the 4th power, and I want to raise it to the 1/3 power. Guess what? It doesn't reduce. That's okay. I can handle this. So I multiply, and I get 2 to the 4/3 power. Okay, crud. That doesn't look like what I'm supposed to be getting. Okay, keep calm, carry on, right? Okay. What can I do with that 4/3?
Reduce.
Oh, goodness, I do not want to multiply by anything. I can't reduce it because there's no factors they have in common.
1 and 1/3?
Oh, convert it to a mixed number. I like that idea. Now, what I'm going to do is write this as two terms. How? 2 to the first power times 2 to the 1/3 power. What's 2 to the first power equal to?
2.
What's 2 to the 1/3 power equal to? Say it again, Serena. And there's your answer. Is your mind blown? It will be when you work on homework tonight. Okay? So, what did I do? How did I figure that out? I used my fractional exponent for my index, my root. I went ahead and multiplied, because when I raise a power to a power, I multiply exponents. I had an improper fraction, so I changed it to a mixed number. The whole number part tells me how many of that radicand I was able to pull outside. The fractional part says what's left behind under the radical, and it tells me what the root is and what exponent is on the radicand. So it gave me all the information I needed to do this. Tristan?
For number 2, can you do 4 cubed?
You could have done 4 cubed. I was just messing with you, wanted to push you. Because some people, you know, it's like I see you guys do this all the time. You get so excited about something, you just keep going, 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 going. Well, luckily for this particular math, there's recovery from that. Okay, you don't always have to stop at that. All right, so let's go back and make sure that we get our fractional exponents in the right spots. Because you guys are pretty good when you have a regular radicand with no exponent and you've got an index that they tell you. But what if it's not like that? So let's do one a little bit more complicated. So what if I asked you to take the 4th root of x cubed? Now, I want you to actually down the line do some math with this, but for right now, if I was involved in having to multiply this with something else that wasn't to the 4th root, then I would have a bit of an issue because I can only have 4th roots talk to 4th roots in root way. But if we go to fractional exponents, it may provide us more opportunities to do more math. So how would I rewrite the 4th root of x cubed using fractional exponents? Okay. Ian, you're like Mr. Yeah, no, yeah, no, yeah, no. Okay, go for it. Okay, I'm going to say that's a great starting step. Can somebody go to the next level with that? He's got everything he's written is absolutely right. Luke?
X to the 3/4 power.
Okay. All he needed to do is go to that one next step. That's now ready to use in other problems. So, where did the 3 come from in the numerator? Where did that 3 come from? Look at your original problem. Where did the 3 come from? The exponent. Give me more. We have some language better than the number that's inside underneath the radical sign. What's his name? Radicand. Okay, I didn't hear that. After all those other words, my head was filled with all this stuff. Okay, so the numerator is the exponent on the radicand. Thank goodness the air got on because I was starting to sweat with you people. Yeesh. All right, and then where did the denominator come from? And let's try to use our new verbiage. Oh, I heard somebody say it. It's the index. Thank you, Connor, for listening. The denominator is the index value. So think the crook. The guy in the crook is the index. Okay. Oh, look at that. Index finger. Crook. Ooh. That's weird. I just thought of that. Okay. All right, let's do a couple of more problems. Again, we're just going to simplify, which again means do all the math that you can do until there's no more math to be done. So sometimes people like to work with the fractional exponents, and sometimes people like to go back to roots because they feel more comfortable. So I'm going to show you two ways to deal with this problem. Okay? What do I know about 8? It's a what? It's a perfect cube, and it's a cube of what? 2. Okay. So if I wanted to keep this the same, I could say, oops, sorry, not 8. He's 2. 2 cubed replaces the 8, and I'm going to raise it to the 1/3 power. And what do I do with the exponents when I'm raising a power to a power? I multiply, so I get what for my final answer? 2. 2 technically to the first power, but we don't need to list that because that just is telling you twice you have 1, 2. That tells you you have 1, 2, and that says you have 1, 2. Okay? So let's talk about it from the other perspective. What if you go, okay, I'm going to first take this problem and I'm going to go back to a radical. And then I've got 4 times 2, 2 times 2. Let's say that I hadn't memorized. And I get the cube root of 2 cubed. Root, the index, and the exponent match. What pops out? Which is called the... What's it called? What's it called? The number underneath the radical sign. No! What's it called? Radicand. Okay, Radicand. You guys scare me. Okay, I know it's been a couple days since you've been in the classroom. Remember, 15 days of teaching is all we got left. 15 days. Well, until the placement test. We've got more teaching after that. But all right, this one. 7 to the 5/6 power. What can you do? There's something you can do. What could you do, Miles?
Radicand where the index is 5 and the exponent, or the number in the index is 5 and the 7's exponent, or wait,
Okay, look directly above.
the 6 is the index and the 5 is the Radicand's exponent.
Okay. That's all you can do. There's not enough 7s to take the 6th root of it. So the only thing you can do is rewrite it into radical form. That's it. Nothing more to be done. That would be it for that problem. I need 6 7s in order to do a 6th root. I only have 5. I can't create another 7 out of the air. The only thing I can do is rewrite it in radical form. Okay? Brian?
If they told you to leave it in fractional exponent form, would you then leave it as the 7 with 5 or 6?
Then you wouldn't be doing anything, so they probably wouldn't say that. But yes, if that was the specific directions, there would be nothing more to be done on that problem. Okay? Ethan?
So if it was like, the index was 6, and then the base was 6, and the exponent was 6, would it be 1?
No. Okay, that's a good question, so let me write it out. Okay, this is scaring me a little bit because there's a little bit of the devil going on in that problem, by the way, if you hadn't noticed that. If I take the 6th root of 6 to the 6th power, what do I get to take out?
6.
The radicand comes out. So it would be just 6, okay? All right, so let's try a couple doozies. We're still simplifying. Let's do some math with these guys. What if I have 5 to the 2/3 power and I want to multiply it by 5 to the 1/2 power? So go back to your rules. Okay, if I'm multiplying monomials and the bases are the same,
Multiply the exponent. Oh, yeah.
what do I do to the exponents? I add. Can I add 2/3 and 1/2?
No.
Okay, what do I need? Wow, common denominators, yes. So, if I multiplied 3 by 2 to become 6, I multiplied 2 by 2 and I get 4. If I multiplied 2 by 3 to become 6, then I have to multiply 1 by 3 and I get 3. Okay? What do I have now? Ooh, I've got an improper fraction, so I can write it as a mixed number, and I can still do more. Patrick. Shh. Oh, nope, nope. Maddie?
Didn't you make it like a 5 and a 1 times 5 and a 1 6?
You can do that. But you're not done. Serena? And that's how you would finalize that answer. Okay? Now, I'm going to give you, in addition to your homework tonight, here's your walk-in tomorrow with your answer. Oh, this is. That's your doozy to work on to have when you come in tomorrow, in addition to the worksheet I'm already going to give you.